Okay, so good day to all of you students. For today's lesson, we are going to continue with where we stopped in the previous video, right? So in the previous video, we already learned how to use the graphical method and also the sign change method to approximately locate where's the root of the equation. Okay, so for today, we are going to learn a bit more advanced one. So for this method, we call it as iteration. So this iteration method can actually help us to get a much more accurate solution for a particular equation. But of course, the solution is only the approximation answer. All right, so let's have a look for the learning outcome 6.2. So from here, what you can see is you need to understand the idea of a sequence of approximations which converge to a root of an equation. So when you see the word converge to a root to an equation, that means um, the iteration that you apply later can actually lead you to a final answer. So that final answer is an approximation of the root. But in other words, they will call it as converge to a root of an equation. Okay, all right. And after that, a sequence of approximation. So when we are using this method, the iteration method, generally you will see that in your steps, you need to list out a list of numbers, which is a sequence of approximation. All right, so the details of how we apply it, we'll learn it later. Okay, so they also want you to understand how a given simple iterative formula. So you need to know what's the meaning for iterative formula. Okay, so it is in this form. All right, and after that relates to the equation being solved and use a given iteration, all right, to determine a root, okay, to a prescribed degree of accuracy. All right, so what you need to know here is you need to actually learn how to use a simple iterative formula. So what is it, we'll learn it later also. Use the formula to help us to determine an approximate root. And in the question, they will always tell you first what is the degree of accuracy they request for. Okay, so like how the equation converge, how the equation leads you to the convergence or leads you to the final answer for the root, it is not important. It will not be tested in the exam. All right, but you need to know whether what is the meaning of converge and fail to converge. So all the details we'll explain it now. All right, we'll discuss it here. Okay, so let's continue with the content part. Okay, so you'll see that the 6.2.1, the topic that we are going to cover now is iteration. So first of all, we need to know what is the meaning of iteration formula. All right, so iteration formula, generally, the idea is very simple. You need to rearrange your equation and you let it become x equals to f equals to another function fx, but it is everything is from your original equation. Okay, so as an example, okay, maybe I just take a simple example. As let's say I'm having x power 3 minus e power x, and it is equals to 0. So let's say I'm having one equation like this. Okay, you can try to arrange it into an iteration formula. So what is the pattern of the iteration formula again? Left hand side is the x, and you move everything to the right hand side. So there are many ways for you to do this. So first of all, you can see that, okay, so maybe I show you the first method here. From x power 3 minus ex equals to 0, I can actually try to move e power x over. Okay, and then because I want to keep the x only, I want to only have the x on the left hand side, therefore I will bring the cube over, become cube root. So I'm having e power x cube root of e power x. So this is one of the iteration formula. So you can see that from the original equation, I try to rearrange the equation, become x on the left hand side and then everything on the right. So this is one of the iteration formula. This one is what you call as iteration formula. Okay, all right, so the other one. So maybe from this original equation again, you should know that there's more than one iteration formula can be rearranged for every single equation. So the red color one is the first one. Okay, so maybe some students are they are not thinking in this way. So maybe they say, can I do it like that? X power 3 and then equals to e power x. And then because they say they know that x power 3 is actually x multiplied with x squared equals to e power x, and they move the x power 2 over, and this equation will become x equals to e power x over x squared. Or when they rewrite it, they'll rewrite it as x equals to x power negative 2 e power x. So can this consider as one of the iteration formula or not? So if you look at the pattern again, you will see that from the original equation, they try to arrange the left hand side become x only, and then the right hand side are some other thing else. So this is also another one iteration formula. So generally you can see that for iteration formula, the meaning is what? The meaning is you try to rearrange another formula from the original one, and just to make sure that left hand side is the x, then the other things you move it to the right hand side. So that is iteration formula. Okay, so maybe you can observe again and see for this equation, is there any other possible iteration formula or not? There's one more that I can think of. So again, for this one, there's another one, which is x power 3 equals to e power x. And then maybe now, I will want to take the x power x down, become the main object. So I'll take ln both sides. Okay, so when I take ln, I'm having ln x power 3 equals to x ln e. So you know that ln e is equals to 1. So ln e is equals to 1, right? Therefore, this equation will become x equals to 3 ln x. So you'll see that left hand side is the x, right hand side are other things from the original equation. So this is what we call as iteration formula as well. So you can see that from one original equation, you can actually derive a different iteration formula. Okay, so you can actually, there are many ways actually. So there are many ways. So you can try to see whether you can create how many iteration formula from one of the equation. Okay, there are many. So in the exam, they won't ask you to try or to arrange so many equations. One usually they will give you one. Okay, in the exam style question. All right, but just to let you know first, so all the equation that created like this, we call them as iteration formula. Okay. All right, so once you understand the iteration formula already, so generally for this part, right, we are going to use all this iteration formula to get the value of x in the equation, to get the root. But again, all the roots here are approximation only, approximation root. That means very close to the original answer, but it is not the final answer, but very close. Right? Okay, so we are going to use all this formula later to find out the x. Okay, so next, let us continue with our simple explanation again. Okay, so to use the iteration formula, usually you will need to have the first or initial value. Okay, so the first or initial value, in this case, you can use x1. Some of the books, they will use x0. It depends on what book, but generally it doesn't matter, because no matter it's x0 or x1, it is just a name. All right, so we call it as first value or initial value. Okay, so when you have the initial value already, then you substitute the initial value, okay, and then they will slowly lead you to get the final approximation root. All right, so first of all, you should know that the initial value or first value, in the question itself, usually they will give it to you, the particular value to start. But if let's say in case in the exam question, they didn't give you the first value or the initial value, then you can found it or you can choose it by the graphical method or the sign change method. So the value is actually related to the graphical or sign change method. So how to choose the correct value, I will show you later also. Okay. All right, so most of the time, the initial value will be given in the question. So that's why I said, if let's say they didn't give you, only you choose it or decide the first value from the sign change method. For me, I usually use the sign change method. Okay. All right. So now the principle about the iteration formula, this one will not be tested in the exam, but if let's say you want to know how can we get the root, then you can have a look for the simple explanation here. So iteration formula, as what I mentioned just now, the pattern is always x equals to something else on the right hand side, right? Okay, so generally what they do is like they try to sketch two graphs. They sketch y equals to x, which is this one, right? Y equals to x, and then they also try to sketch y equals to fx. Okay, so this is y equals to fx. All right, so you're having two here. Then now, x equals to fx, this is iteration formula, right? It is actually come from the original equation that we want to get the root. Okay, so now when we arrange it like this and we draw a pair of graphs separately, where is the root actually? So you, from the graphical method that we learned before, you know that the root is actually this one, the intersection point, right? So for this example, you will see that you're having two intersection points here. Okay, right, so you want to get the value of the root. Okay, all right, so now the concept is like this. Okay, so first of all, you need to have the initial value. Okay, so let's say initial value is x0. I use the name x0. You substitute to the function fx. So when you substitute the function, the value f0 into the function fx, you will get this one. Okay, so you get this one. When you get this value, fx0, you let it equals to x. So you let it equals to x means that you move the value here. Okay, then now you want to repeat this process. That means now this value itself, if I look at the x here, I make it as x1. The next value is x1. So when you substitute to x1 into the function fx again, so at first you put it into fx. So you assume that this is x1, you get an x1. And after that, you put the x1 into the function f again, then you get x2. How to get x2 is you substitute in into the function f. This is your fx2, fx1. So you let it equals to the x, right? So this value of x, I assume that it is x2. Sorry, so this is x2. Okay, then for the third one, you substitute x2 into the function again. So when you substitute into the function, this is what you get, fx2, and you let it equals to the x. So now this new x here, I name it as x3. Okay, so for this new function, the new value here, so I will call this as x3. Okay, so if you can see if I repeat this process, again and again, right? When I repeat again and again, eventually it will get very, very close to the intersection point value. So this is how we get the root. Okay, the approximation root. Right, so for this is the principle about it. Okay, I can't find a video to explain in detail, but generally this is how they work. All right, but of course they won't ask you all this in the exam. Okay, but this is just to let you roughly understand how we actually get the answer. Okay, all right, so as an example, this is the explanation. All right, this is the explanation of the graph just now. If you want, you can have a look and see what are they discuss, what are they show here, what they show here. All right, but generally the process is like what I mentioned just now. Okay, all right, so that's why iteration formula can be used to look for the approximation root. Okay, so these are the explanation. You can have a look here for all this part. All right, okay, so now for us, we will focus more on the application part. All right, so I want to discuss one example with you here, which is example 5. Okay, so example 5 is actually one of the partial question. All right, so for one of the complete partial question, usually you will see that they consist of a few different parts. They have part 1, part 2, and part 3. So let's discuss it together. All right, so they tell you that for this equation, there's a root. Okay, of course, if you're having calculator, right, straight away press calculator, you can get the answer for the root. Okay, but now they want you to use the method that we learned before to locate where is the approximate root. So you need to follow the steps and answer lah. So first, they ask you, show by calculation that the root lies between x equals to 1 and also x equals to 2. Okay, if you look at this question, they want you to show it by using calculation. So that means you need to apply the sign change method, okay, to complete this one. All right, so if you want to test your understanding, you can pause the video here and try with the sign change method that you learned before first. Okay, then after that only you come back and check the answer. So to use the sign change method, I need to let fx equals to the equation. That means I move my whole equation to one side and the other side becomes 0. Okay, then they already give me the value to substitute, x equals to 1 and also x equals to 2. So when I substitute 1 into the equation, I'm having -3. And then when I substitute 2 into the equation, I'm having +2. So very obvious, I can see the sign change happen between F1 and F2. So this part, you need to do the conclusion by yourself lah. Okay, so I already showed you the conclusion in the previous video, so please have a look in the previous video. So please make sure that you write out the conclusion. All right, so here we've done the first part. Okay, so for the second part, they want you to prove that if a sequence of the value given by the iteration formula, this is the iteration formula given, converge, then it converge to this root. Okay, so now when they give you this kind of question, it looks like very complicated, but generally the meaning of this question is they want you to prove either you start from the iteration formula and you prove back how to get the original formula. Okay, or the other way around, you can start from the original formula, you rearrange it and try to get this one, the iteration formula. So the question looks like very hard and very difficult to understand, but for this kind of question, part number 2, they ask you to, when you see them using all these words, then generally they just want you to prove from original to iteration formula or from iteration to original formula only. You can see which one is easier for you, then you just try to prove. Okay. All right, so for me, I will start from iteration formula. So what is the iteration formula that I'm having here? It is x. I will just ignore the n plus 1 and n all those things. All right, it is just the name. Okay, so for the x, so I will just write x equals to 2x power 3 plus 2 divided by 3x squared minus 2. So this is my iteration formula, and I'm trying to arrange it become the original formula. So very obvious, I can bring up the denominator to the other side. And after that, I can have 3x power 3 minus 2x equals to 2x power 3 plus 2. Okay, then after that, to get the original formula, I move everything over. Then very easily, I will get x power 3 minus 2x minus 2 equals to 0. So this is what you have for part number 2. And the process is very, very simple. As what you can see here is, you just rearrange the iteration formula, become the original one. If you want to arrange original to the iteration formula, also no problem. All right, just make sure that when you look at the style of the question, usually they will ask you when the iteration formula converge, then it converge to this root. Okay, so they didn't ask you to prove, but the meaning is actually want you to prove it. Okay, so this is how we do it for first part and the second part. And the third part now, okay, we come to the main point. They want you to use the iteration formula to calculate. All right, so to calculate the root correct to 2 decimal places. And after that, give the result of each iteration to 4 decimal places. Okay, so your final answer, they want you to use the iteration formula to get the roots now. All right, and after that, your final answer should be in 2 decimal places. But when you list out the sequence of approximation, every iteration you must have 4 decimal places. So these are the accuracy that requested by the question itself. Okay, they will mention clearly what they want. All right. Okay, so maybe we can start now to do on this part. All right, so this is the third part. First of all, I will write out the iteration formula again. Okay, so to use the iteration formula to get the answer, okay, do they give you any initial value or not in this question? So for part number 3, if you read through it, they actually didn't give you any initial value. All right, so if we want, we can assign one value myself. I write as x1, you want to write as x0 also can. All right, so how to determine what is the value of the initial value that I can use it? Usually we'll refer to the x value that they ask us to substitute in the sign change method. We can substitute any value between 1 and 2. Okay, any value between 1 and 2, not negative 3 and 2. So depends on the value of x between 1 and 2. You can substitute 1 if you want. If you want, you can substitute 2 also. You can substitute 1.5 as long as any value between these two. All right. Then usually for me, I will choose a value which is closer to 0. If I choose the value which is closer to 0 means that this one, which is closer to 0, the 2 here, right? So that means I will select the 2. It depends, all right? Because if you choose the correct value, that means your iteration later, your steps later will be much more shorter. But if you substitute it if you substitute it wrongly, then that means you still can get the answer finally, just that maybe your steps will be slightly longer. That's the difference only. All right, so it depends on which one you want. Okay, all right, so I'm having x equals to 1 and x equals to 2. Maybe for me, I choose the middle value, which is 1.5. Okay, all right, then I want to get my x2. All right, so how to get my x2? I need to use the calculator to help me. Okay, so here I show you one example. I hope that you can see it clearly. All right, so now, first of all, you need to key in the iteration formula into your equation. All right, so when you want to key in the iteration formula, only key in the right-hand side of the iteration formula, which means that you only key in this part. All right, and please make sure that you key in it correctly, because if you key in the formula wrongly, that means later your final answer will be wrong also. All right. Okay, so when I want to key in this one, this is how I key in. I'm having 2x, so alpha power 3, okay, then plus 2. All right, and then what do I have here is 3x squared plus, minus 2. Okay, so you can see that I key in the right hand side of the formula. And then now I want to try to get the value for x2. So how to get the value of x2? Once you key in the formula correctly, you click on the calculation, CALC. Can you see that? So you click on the calculation, your calculator will ask you what is the value of x. So you key in the first value that we have, which is 1.5. So I will type in 1.5 here, key in 1.5, and I press equal sign. So when I press equal sign, my answer the answer that I get is 35 over 19. But in our question, they actually request your iteration to be 4 decimal places. Therefore, I need to change it become decimal number. So the decimal number from here, you can see that it is 1.8421, 4 decimal places, right? That means in the x2, the value of x2 is 1.8421. All right, so I will just write it here first. It will become 1.8421. sorry, I maybe use the purple color, 1.8421. Okay, then now I want to get the third value, x3. Okay, how can I get the value x3? So from the screen just now in the calculator, okay, don't press anything. You just press the calculation button again. Press the calculation button again. They will ask you again, what is the value of x? So now you please key in the second value here, which is 1.8421. Then you press equal sign again. All right, so the next number that you get is a long number here, but I just want to keep it to 4 decimal places, which is 1.7728. So in my iteration list here, I'll write it as 1.7728. Okay, so what will be the next value? Okay, so I repeat the same process again. Press the calculation button and then key in the value 1.7728, and I'll get 1.7693. Right, so I will put in as 1.7693. Then x power 5, x number 5. Then again calculate, and then you key in 1.7693. So I'm getting this 1.7693 also. So 1.7693. Okay, so I can stop here. But if let's say you cannot get the repeated same values here, then where should you stop? Generally, what you need to do is like you just need to double check, because their final answer, they only want to have 2 decimal places. Okay, 2 decimal places. Therefore, you can always double check your 2 decimal places answer. Like here, it is 1.77 for 2 decimal places. This one is also 1.77 for 2 decimal places. So actually, if you want to stop here, you are allowed to stop here. Okay, you don't need to continue to x5. But sometimes I want it to be safe. I want it to be on the safe side. Usually I will try 1 or 2 more iterations. Okay, so it is not wrong actually. But if you want to stop at x4, it doesn't matter. It's okay, because the both answer for x3 and x4 is already fixed up, which is 1.77. Okay, then you need to write out the final answer. So the final answer is, you need to write out the root is equals to what value? 1.77. So again, please take note that for the final answer root, they only want it to be the, how to say, 2 decimal places answer. Therefore, I just keep it as 2 decimal places here. Okay, then all the x1 and then x5 is what we have. All right, so all this part, okay, we will call it as iterations. So all the iterations are in 4 decimal places. Okay, and then this one is in the final answer, the final answer for the root. All right, okay, then now this is usually how I teach students, okay, about the iteration here. Okay, so now from now onwards, I will want it to be on the safe side again. For the first, wait, let me have a look. Okay, so for the first iteration x2, besides the 1.8421, maybe you can put in 1 time. You can write out 1.5 power 3 plus 2 divided by 3, and then 1.5 squared minus 2, and it is equals to 1.8421. You just write out the formula once, just in case that they request for it, because I don't know, I can see some of the books or some of the marking scheme, they actually suggest or they recommend to write out the formula once. All right, so to be on the safe side, I think better we write out once. Okay, so you can see that all the iteration, I give the answer in 4 decimal places, and for my final answer, I give it in 2 decimal places only. So this is how we use the calculator to apply it. All right. So you can see that for the calculator part, this is the only way I can show it to you. I hope that it is not too small for you to look at it. Okay, and then just a reminder, if any of the iteration formula that involve the trigger like sine, cos, tangent or whatsoever, you have to ensure that the mode of the calculator is in radian mode. If not, you won't get the correct answer. All right, okay, so I think I will stop here for this video, and then we'll discuss more in the next example. All right, okay, so that's all for this video for now.